In this video, we'll be solving a new problem, new Leetcode problem. It's called symmetric tree. And here in the problem, we are given a root node of a binary tree, and we want to check if the tree is symmetric or not, or if it's we want to check if it's a mirror image or not. You can see in example 1, 1 is the root node, and we have a left subtree and right subtree, and we are checking if those two left subtree and right subtree are symmetric in nature or not. It means that if one subtree is a mirror image of another or not. You can see the left half and right half of the tree are not equal, because you can see this tree at the position where there is 3 in the left subtree, there is 4, but which means they are not same, they are just mirror images, and therefore the output is true. But if you look at example number 2, the left subtree and the right subtree are exactly equal, but they are not mirror images, and therefore the output is false. This problem is very similar to the last problem we solved, which was to check if two binary trees P and Q are equal or not. In this, if you look at the right, I have already written the solution, and this I have a function called isSymmetric, and it takes the root node of the binary tree and returns if it is symmetric or not. And this function is calling another function where this another check symmetric function is a recursive function, and it takes the left subtree and the right subtree of this root node. And the check symmetric function is very similar function to the last function we made, is same tree or not. If you look at the conditions we are using, they are almost identical. You can see we're checking if the left subtree and right subtree have ended together or not. If they have ended together, they are structurally same, so we return true. They are symmetric, or they are also equal in both sense, right? And we also have two more conditions to check if one of the subtree has ended and another subtree has not ended. These are two conditions that check that, and in that case they're structurally not the same, and therefore definitely not symmetric, so we're returning false in that case. We're also checking if the value at left subtree or left node is equal to right node value or not. If they are not equal, it means they are not same or not symmetric in our case. Now, what makes this check symmetric different from the last solution is this part, this recursive part. You can see in this case we have called the same function recursively twice. One is to check if the left subtree's left half is equal to right of the right subtree. Now, if you recall the earlier function to check if the two binary trees are same or not, what we are doing is we are updating P and Q with the same left. We are basically shifting both subtree to the left and also to the right at the same time to check if those two subtrees are same or not. But to check symmetricity, we want to go in two different directions. We want to go left for one of the subtree and right on another subtree, right? And similarly, when we go right of this left subtree, we want to go left of right subtree. So that's the only difference we have here, and the other conditions are checking if those trees are same or not. And this should pass all the test cases, and also let's see, yeah, it passes all the test cases and should be a good submission. And that's right, that's our solution.